So over the last few weeks, I've received a lot of questions about back titrations, which is why I'm making this little video here. Now, this question here is a type of back titration question. And the first thing I suppose that you should really think about is, how do I know it's a back titration compared to just a normal titration? Well, the answer is, generally with a back titration, we've got two main steps happening. We've got an original sample, which we're titrating with something else, but the endpoint isn't really clear, so we have to do another titration as part of it in order to get our answer. So what we've got here is a question which is pretty much worked example 4.4 of Heinemann Chemistry 2. We've got a 150 gram sample of fertilizer, and it was boiled with 25 mils of 0.987 molar sodium hydroxide solution. I'm just going to underline those points there. When no further ammonia gas was evolved, it was cooled and titrated with 0.2132 molar hydrochloric acid. A titer of 19.78 mils was required. Calculate the mass of ammonia ions present in the fertilizer. So already what we've got here is a whole lot of information, and the first thing that we should possibly do is define what our variables are in order to solve the problem. So the first thing that we should do is, number one, we need to calculate the amount of mole presence in the original solution of base. So we can do this by looking at how much acid there is. Now, first of all I want to write a balanced equation for this reaction. So I know I've got sodium hydroxide because I'm told that, and I know ultimately, as it says here, it's reacting with hydrochloric acid, so HCl. So what we've got here is a standard neutralization reaction, and of course I'm going to include states because examiners love states. This is our balanced equation. Now, back to the original question. Now, the information that we can deal with quite successfully is the fact that we were told we had 0.2132 molar and 19.78 ml of hydrochloric acid solution. So let's figure out the amount of HCl that was present in the solution, which is going to be 0.2132 molar multiplied by 0.01978 litres. Again, we use litres. And the answer that we get there is 0.004217 mole. So that's the first step. The second step is to see how much of our base, or our sodium hydroxide, is reacting in relation to our amount of mole of acid. And as we can see here, what we've got is a 1-to-1 relationship. So what that means is that our amount of mole of hydrochloric acid should theoretically be equal to our amount of mole of sodium hydroxide, indicated by our coefficient out the front of these two parts. So what that means is we've really got 0.004217 mole. Okay, so this is the amount that we've got present. I'm just going to write present here. Our next step is to calculate the amount of sodium hydroxide that's actually reacting. Okay, so the way we do this, I'm just going to write reacting here too, just so I can sort of figure that out, is to take our original amount of mole, which we haven't actually dealt with yet. So we're told that we've got 25 ml of 0.087 molar. So let's just very quickly figure out our amount of sodium hydroxide at the start. Okay, let's just zoom that out, and that's going to be equal to 0.9987 molar multiplied by 0.025 litres again, which is equal to 0.02497 mole. Okay, so this is how much we started with. So we take that amount, 0.02497 mole, and now we want to subtract this amount here, which we've just figured out. And I'm just going to do it underneath here because I've got a feeling that my lack of space means I'm going to soon run out. And what we get there is a grand old total of 0.02075 mole. Okay, you should be happy with that. Now, this is the amount of mole that's actually reacted. What we want to do is relate it back to the original statement. Now, the original statement, we were told that it was reacting with our NH4 plus ions present in the fertilizer. And if we were to write a balanced equation, what we would see is the following. So I'm just going to rub out what we had at the top here, because that's now done. Okay, so I might use red just to show a bit of contrast. So our original equation was this. We told we had our ammonia ions and they were reacting with our OH ions. And of course, we want to include states. Running out of room. Okay, beautiful. Now we can see here that we've got a one-to-one relationship. Therefore, what we can say is our amount of sodium hydroxide, okay, which we've established here as the amount reacting, is going to be equal to the amount of mole of our NH4+. Now, our ultimate goal is to figure out our total mass of our NH4+ or our ammonia ions. So, of course, then we just go back to our basic stoic, and our mass of NH4+ is going to be equal to our N multiplied by our molar mass. And I'm using MR just because some of you are still getting confused with a molarity, which would be 0.02075 multiplied by 14 plus 4 is 18 grams per mole. Okay, and our final mass that we get out is 0.3737 grams. If we go back to our original question, let's have a look. The information that's relevant to what we're asking, all of them have 4 significant figures. So that 4 significant figures is fine.